All right, welcome back. Hope you enjoyed your day off yesterday. We had homework day 2 for 6.2 as your assignment. That answer key is posted in the Unit 6 folder under Schoology. It is also posted at the back of the room. There are 4 copies of it on the back whiteboard that are stuck up there with pins. So you guys are with tags. So you guys should be able to see that. It's labeled on the board, so you can go there and look at it or go on Schoology and check your answers. So today I am going to help you with the setup for our word problems for day 1. I will be back tomorrow. I'm just out for today with a doctor appointment and medical procedures. So I will be back tomorrow. So in this first problem, we have to define our variables and then write a system of equations and solve. So I'm not going to do the solving part, but I will help you with the setup with a number of these to get you going. So we've got Phil. He went to Century and he bought 2 different things. He's got pounds of hamburger and bags of chips. And Mrs. Jackson did the same. So you can see the first thing we did, we identified our 2 variables, pounds of hamburger, bags of chips. Next, we can write an equation for both Phil and Mrs. Jackson. So that first equation, you can see that's what Phil bought. The second equation is what Mrs. Jackson bought. So she bought 3 pounds of burger, 5 bags of chips, $32.92. You can see Phil, 2 pounds of burger, 1 bag of chips for his total of $12.17. You have the option now how you solve this. You can solve this top equation for y if you'd like and plug it in down here to get x and then circle back here, or you can multiply the top one to eliminate x or y and go that way. So that is your choice, but you now have the setup for number 1. So I will proceed on to the next problem. Okay, problem 2, we've got the Smith family and the Jones family. They're both going to a Broadway production of The Lion King. I'll let you read the problem on your own time. And again, you can pause this, go back as many times as you need to. So there's 2 types of tickets for this particular production. We've got adult tickets and children's tickets. That's pretty typical for most Broadway shows. So there is our variables. So we'll start with the Smith family. They have 2 adult tickets and 3 kids, and there was their total. And put dollars here. You could if you want. It doesn't matter. Not until you get to the end. When you write your answer at the end, then you want to write it as ordered, paired, in context with label. So there's the Smith family, and then we have the Jones family, and they had 3 adult tickets. So apparently grandma or grandpa's tagging along, possibly aunt or uncle, and they got 5 kids, bless their hearts, and they paid $270. So 8 people going. It costs about an extra $100 for that. But again, you have your system here. This time I would definitely use elimination. I would probably multiply these to either get rid of x or y and proceed. But again, you got the variables, you got the setup, you're ready to go. And I believe there is one more on this page, so we'll scroll down. Yeah, we got the job offer. Okay. This one's going to be slightly different because this one's going to be set up as an inequality, but we'll talk about it here. So you got a sales job selling dental supplies. One company offers straight commission. That means you only get paid off of the sales that you make, and you can see here that's 6%. So if you sold $10,000 for the month, you would get 6% of that, which would be $600, or in a week, I should say. So if you sold $10,000 in a week, you'd get $600 would be your commission. That would be your check. The other company offers what's known as a draw. That's this salary here, $350 a week plus 3% of the sales. So you want to see what your sales would have to be in a week in order to make the 6% job the better offer. So we'll let X be our sales. We'll let Y equal our pay. And so you can see here's job offer 1. Job offer 1 is the straight commission, 6%. Job offer 2 is the $350 a week plus 3% of sales. Again, this is going to be an inequality because we want to know when this number is greater than this one. We have two quantities equal to y, so we can set them equal over here. So again, we are figuring out at what point, what amount of sales is the offer from company 1 better than this offer here. And I think I misspoke. I said we have one more on this page, but actually we have one more now, and that is the break-even problem. So let me get down there. So we got fast food place, kind of like a Robert's, mom and pop place, if you will. They are investing $5,000 to produce a new food item. So that could be for a new grill, that could be for a new ice cream machine, doesn't matter, but they're going to have $5,000 invested so they can put up this new sandwich or ice cream item, whatever it is that they got. They're going to sell it for $349. The cost to make each one is $216. So it says how many items must be sold. There's two parts. It says how many to break even and how many to make $8,500 in profit. When you break even, that means your profit is zero, which also means that your revenue equals your cost. So the money going in equals the money going out. Here we'll have our profit will equal $8,500. We're going to let X be the number of items that we sold. And you may remember from earlier in the year, because we've done these problems before, profit is equal to revenue minus cost. So the money you take in minus the money that goes out, what's ever left is your profit. So for that first one, for part A, we want to know the break even. So we want to know when revenue equals cost. And so we'll go over here. Our revenue, we're making $3.49, or we're charging $3.49 for each item. And our cost is $5,000 plus $216 per item. So revenue will equal cost when we break even. So there's my first equation. You just solve that for X. That will tell you how many items you need to sell to hit that break even point. The second one, a little more complicated down here. So now you got a profit of $8,500. So now your profit is going to be revenue minus cost. So your revenue, $349 per item minus your cost. Be careful right here. Make sure you distribute this negative first before you combine like terms. And then that will tell you how many items you need in order to make $8,500 on that particular item. So that's the setup for page 1. We will now jump to page 2. All right, we got some apple juice and orange juice here, 8-ounce glasses, and we're talking about how many milligrams of vitamin C are in each. And so we'll start with our variables. So we got X and Y. X will be our glasses of apple juice. Y will be our glasses of orange juice. And you can see I left this one blank here for you. So you got the two variables, but we know we have two different situations here. Here we got 1 glass of apple juice, 1 glass of orange juice, total milligrams of vitamin C. Here we got 2 apple juice, 3 orange juice, and how many milligrams. So you should be able to set that up and solve accordingly. Biggest thing, identify the variables first, then we can get the system of equations. Probably going to end up using substitution for this one, although you could multiply as well. That's your call. Okay, number 2, the infamous mixture problems. So we are trying to obtain a 30% acid mixture. We had one similar to this the other day. It was with gasoline mixing. I think it was E85 and E15 to get E40, 40% ethanol. So now it's the same idea. We're just mixing an acid mixture instead of gasoline. So we are going to mix a 20% acid solution with 50%. And we want to write a system of equations to represent the total mixture. All right. So I will start. First of all, they give us the variables. They tell us X is the 20% and Y is the 50%. So that helps us there. How much is needed to obtain a 30% acid solution. And again, right here, if you skipped over it, first two words in this problem tell us our total mixture. So we want 10 liters of the 30%. All right, so we got our variables. I'll go over to the picture here first. I think that makes it a little easier. So we have X liters of this 20% that we are going to dump into this mixture. And then we've got Y liters of the 50% that we will also pour in here. So again, you're just taking the two, dumping them together, and we're going to end up with a 10 liter total mixture at 30%. So here's what we know. We know we have 10 liters total, so X plus Y has to be 10. There's our first equation. Second equation is the mixture itself. So we know X is a 20% solution, Y is a 50% solution, and we know that the entire mixture is 30% times the amount, which we know is 10 liters. So again, this will give you everything you need. Again, you can do substitution or multiply and do elimination. That's your call here. Probably it'll be cleaner to do substitution, in my opinion. All right, last two problems, very similar. So we'll show you the setup for the one that should help you with the next one. So we got an investment portfolio. Not that any of you are experts or have delved into that realm yet, but when you invest money, you typically will diversify, which means put it in multiple accounts. That way, if one does well or one does bad, you're not, taking a huge loss on all your money. Hopefully, the gain of one will balance out the loss of the other, or if they both gain, great, and if they both lose, hopefully one still outperforms the other, so you don't take a huge loss. So we've got $12,000 invested, two different bonds here, 7.5%, 9%. We want to earn our interest. So we'll start with our variables. We have X dollars in the 7.5% account. We have Y dollars in the 9% account. We know the total investment, the total sum between the two accounts is $12,000. And now we use the interest rate. So the interest rate of X and the interest rate of Y equals the interest we're trying to earn, which is $990. Don't forget to change your interest to a decimal. Otherwise, you're going to get an answer that is not close. It'll be way too big. So again, change your percentage to a decimal for the interest equation. So the last one is very similar. I didn't do the whole setup. I just gave you the variables. So in this case, slightly different. You got 32,000, so you can compare that to up here. And you got a 5.75% account and a 6.25. So based off what I gave you up here, you should be able to do the setup for the last one. Make sure you have this done for tomorrow. That is the expectation, especially since I have set these up for you. I expect you to have these done and ready to roll when we get to class on Thursday. All right, have a great day. We will see you tomorrow.